All right, so the title of this activity is writing equivalent expressions using the distributive property. So once again, an equivalent expression is just any expression, or any two expressions rather, that if you plug in a number for x or a variable, you will get the same answer. So we're working with the distributive property here, and so there's two different directions that you can move in the distributive property. So the first one is what we see in row 1. This is what typically comes to mind when someone talks about the distributive property. So that's taking that factor on the outside and multiplying it by both or every number, depending on how many numbers there are, inside the parentheses. So here, this number 3 is going to multiply by the 3, and then this 3 will also multiply by the x. So 3 times 3 is 9, and 3 times x is 3x. So once again, to prove that these are equivalent, let's say x was 2, and we did 3 times 3 plus 2, 3 times 3, and then 3 times 2. 3 times 3 is 6, and, 3 times 3 is 9, and 3 times 2 is 6, and I would get 15, okay? And then we could also plug it into this equation, 9 plus 3x, but I'm going to substitute in 2 for x. Using the order of operations, we would have to do 3 times 2 first, so this would turn into 9 plus 6, and we get 15. So once again, these are equivalent expressions. If I plugged in a number for x, I would still get the same answer. So once again, distributive property, multiplying by every number on the inside of the parentheses, and we get this new expression. Now, the second row, though, is going backwards. So we need to turn this into a problem with parentheses. The way we do that is through the process of factoring. And so factoring means pulling out the GCF. Okay, so we're going to find the GCF of both terms that I have in my expression. And whenever you pull out the GCF goes outside the parentheses, and then you divide the terms by the GCF, and that stays in the parentheses. So those are kind of the steps of factoring, and so that'll make more sense as we do an example. So 4x minus 20. So the GCF, the greatest common factor, is the biggest number that both terms can be divided by. Okay? So I know that 4 can be divided by 1, 2, and 4, and 20 can be divided by 1, 2, 4, 5, 10, and 20. The biggest number that it can be divided by is, that this can also be divided by, is 4. So, like we said here, we pull out the GCF, so the GCF is going to be 4. So, the GCF goes outside of the parentheses, and then what's left in the parentheses are the terms that are divided by the GCF. So, if I did 4x divided by 4, that would leave me with just 1x. And if I divided 20 by 4, that would leave me with 5. And now, the thing is, now that I factored this, if I did the distributive property, 4 times x and 4 times 5, it would get me back to this problem. So multiplication and factoring are like inverses. They just undo each other, and then you can just go back and forth between them forever. If I multiplied this out, I would get this, and then if I factored this, I would go back here. Okay. So, if you would like to pause this video at this point and then complete the table yourself, feel free to do that now. Alright, so now let's go over the rest of these. So here, I have x is my factor on the outside. So, and it's on the right. That doesn't matter though, order and multiplication doesn't matter. I'm still going to do the same thing. X is still going to multiply by the numbers inside. Anytime a variable multiplies by a number, it just attaches itself. That next to notation, I can't do anything else because I actually don't know what x is. So it would just be x times 9 is 9x and x times 5 is 5x. You need to keep the symbol that was there. Okay, so let's look at this next one. What's the biggest number that both 4 and 7 can be divided by? Well, 7's actually a prime number. So 7 can only be divided by 1 and 7, and 4 is not divisible by 7. So as far as our coefficients are concerned, the numbers out in front, there is no GCF. However, they both share a variable. They both have an x, so x is a factor of both of them. So the GCF goes outside the parentheses, and if I divided these both by x, or took the x away from them, then I would have 4, and I would have 7. Alright, and once again, if I did the distributive property and multiplied back out, I would get back to this problem. Here, 3 multiplies by both. 3 times 2x is 6x, plus 3 times 1 is 3. Alright, here, GCF. 5 is the GCF here. I'm going to make it a habit of writing the GCF off to the side. So, because 5 can be divided by 5, and 10 can also be divided by 5. GCF always goes on the outside, and then we have to, if we take out the GCF, these terms both need to get divided by it. 10x divided by 5 is 2x, and 5 divided by 5, any number divided by itself is 1. Alright, here we have 3 terms, but that's okay. You can have 1,000 terms. You can still use the distributive property and factoring to write an equivalent expression. So once again here, there is no coefficient in front of this x. It's just 1x. So if you want to put a 1 there, you can. That's up to you. 1x and just x are the same thing. Once again, as far as the coefficients are concerned, the numbers in front of the variable, there is no GCF. 1 is the biggest number that can be pulled out of all of those. That wouldn't actually change anything. But once again, they do all have an x. So the biggest factor here that they have together is x. So the GCF would go on the outside. And if I divided all of these by x, or if I took x away from all of them, then it would just be 1 plus 2 plus 3. Once again, if I distributed or multiplied those back out, I would get this equation. Here, 1/2 times x is just 1/2 x. And then 1/2 of 6, 1/2 of 6, or 1/2 times 6, is 6 over 2, which is 3. Here, this problem's a little bit funky because these terms already had variables, 3x and 4z. The same rule as before applies though. Whenever you multiply by a variable, the variable will just attach itself to it, becoming another factor of the number. So 3x times y is just 3xy, and y times 4z would be 4yz. Technically, the order of your variables doesn't really matter because, remember, this is next to notation, so these are numbers that are attached to each other with no operation symbol. That's multiplication. Order does not matter in multiplication. So if I had 3yx instead of 3xy, it would still be equivalent. It would still get me to the same product or answer. The only reason why I have my variables the way I do, I like to have my variables in alphabetical order. And you can see down below that they did that as well. GCF here of, let's look at the coefficients, 2, 3, and 4. 3 is prime, and 2 and 4 are not divisible by 3. So once again, as far as the coefficients are concerned, there is no GCF, but they do have variables in common. This one doesn't have an x, but these two do, so that's not a shared factor. These both have y, this one doesn't, so that's not a shared factor, but they all have a z. So z would be the factor I could take away from all of them. And if I took the z away here, it would just be 2xy. Here, this would be 3y, and this would be 4x. And then once again, if z multiplied back throughout to all of these, did the distributive property, I would get back to this equation. All right. Now, just a few more problems. For extra practice, you'll have practice problems to do independently as well. So, distributive property, this is the multiplication section where we're multiplying out. 3 times 5 is 15. 3 times a is 3a. Once again, as always with these videos, if you would like to pause so you can go through and answer these problems solo first, that's a really good idea to kind of push yourself to see what you do know, and then you can always just resume the video to see how it finishes to check your work. 6 times 2a is 12a, 6 times 5 is 30. Once again, here I got a factor on the right side. It doesn't matter. Order doesn't matter in multiplication, and I'm still just going to multiply out. 3 times 5x is 15x, and 3 times 4x is 12x. And then here, multiplies by both. 15xy minus 8x. Okay, because once again, when a variable multiplies by a number, it just attaches itself to it, forming that next to notation, and then order doesn't matter. It could be 15yx, but once again, I like to keep things in alphabetical order, and that's typically how you'll see it throughout the rest of your math career. Now down below, all right, so this is where we're factoring. So factoring means find the GCF to factor out. 15 and 3, well, 15 is divisible by 3, so that would be the GCF. GCF comes on the outside, and then both of these terms, since I took the GCF away, I factored it out. If you take a factor away, then you need to divide everything by that factor. So 15 divided by 3 is 5, and 3a divided by 3 would be 1a, or just a. GCF here, biggest number both can be divided by, would be 6. And so if you pull out a GCF, then you divide your terms to leave in the parentheses. 12a divided by 6 would be 2a, and 30 divided by 6 is 5. GCF here, the biggest number both can be divided by is 3. And they both have an x as well. So my GCF here actually isn't just 3, it's 3x because they also share a variable together. So I need to divide both by 3x. 15x divided by 3x is just 5, and 12x divided by 3x would be 4. Okay, and then here, 15 and 8, those coefficients actually do not share any factors together, but they both have an x. So x is the GCF. This would be 15y minus 8. Okay. And then if you go back and look, once again, just to show that multiplying and factoring is the opposite, the answers here were actually the final problems here and vice versa. You can see here, though, difference factors on the back here, front here. That's okay. Order doesn't matter. And then here, this problem, the x isn't on the outside like it was here. But technically, if you did pull out the GCF, the x should have been out here. But once again, the idea that multiplying and factoring are opposite kind of operations.